is the first derivative of some function. You can tell this little mark there, indicating it's the first derivative. So you had some function, you took the derivative. I'm not going to do, you're professionals at taking derivatives.
Yeah.
Here it is. I'm going to use this derivative to draw myself a picture of the original function.
Ooh,
yeah.
Neat.
And here's what I always say to my students. When you're looking at a derivative, look at where the y values, or what would make the y values either 0 or undefined.
Fantastic.
I want to know what would make this thing 0 or undefined. Well,
that would give me the critical
those would give me critical points. I'm sorry, I didn't say that part.
Function.
Those would give me
That's
critical
okay.
points. Right. Is there any way to make this thing 0?
Gosh, no.
No. There's no 0 in the numerator.
Yeah, and you can't
Yeah.
get a 0 out of a function.
You cannot. That's
You can only get it from the denominator.
That's right. So is there a way to make this thing undefined?
I would say
there
yes.
certainly is. Now, really, do I have to worry about this exponent at all, really, at this point?
Well, you don't, because you're just wanting to see what x value would produce a 0. And so 0 raised to the any power.
That's right.
Except for 0.
All I have to do is make this inside 0. I mean,
Yeah.
this is really not too bad. I'll subtract 1, so x equals -1/3.
So
That is a place where the denominator is 0. It is a place where the first derivative is undefined.
Beautiful.
It is a critical point.
Love it.
So I'm going to make a little picture right here, as I always do. -1/3. Now I'm going to pick a point on each side. I don't know, I'll pick -1. Is that working for you?
That's smaller than -1/3. That's
In fact,
working.
it is. I'm going to put -1 in here. So that's -3 plus 1. Well, that's a negative value.
Okay.
But if I raise it to the 4/5, I mean, I know this looks intimidating, but it's really not. Anything raised to the 4th, really this says raise it to the 4th, then take the 5th root. Anything raised to the 4th power is going to end up positive.
Because it's an even exponent.
That is correct. Negative times negative times negative times negative, is that 4?
Yeah.
That's going to end up being positive. Or
Good.
positive times positive times positive times positive is positive. And then when I take the root of a positive, it's still going to be positive.
Beautiful.
So this bottom's always going to be positive. The top,
Negative.
always negative. Negative over positive,
Negative.
negative. I'm going to pick something on this side. Go ahead.
So you're saying that's a negative slope.
That's what I'm saying.
Okay.
I'm saying this thing ends up being negative. This is my derivative. It tells me about the slope of the original function.
Fantastic.
Stick in a 0.
That gives
It's gotta
me
be
a
1
1 to the
Blah,
4/5.
blah, blah. Hey, it's still positive.
Positive.
Negative over
It's
positive.
still negative.
Right. So these are the slopes of my original function. My original function goes downhill, and then something happens and it goes downhill
The
again.
slope is undefined is what happens.
That's right. It's not a 0 slope, it's an undefined slope. So really I'm forced to go downhill, undefined, downhill again.
Ah. Now
And
how
that
do
is
you
my
know it's not one of the pointy ones? How do you know it's not going to be a sharp corner? Because that could also be
Well, I mean,
undefined.
right. I mean, it would be impossible to draw it. That would have to go downhill and uphill, or uphill and downhill. That would have to
Right.
change slopes.
And another question might be, how do we know it's not an asymptote in the original function? And that we just know because we're assuming that
Exactly.
our function
We're gonna
is defined
assume
for
that
all
the original
numbers.
function is defined, right, for all x.
That's beautiful.
Yep. Thanks.
Very nice.